Okay, guys, so you have some notes that you can fill in from the PowerPoint, but the main thing that I want to make sure that we go over is this phase change diagram. Now, in a phase change diagram, you have pressure, which is measured in atmospheres, which is often abbreviated as ATM, and we have temperature on our x-axis, which is measured in degrees Celsius. Now, a phase, remember, is a phase of matter. So we have solids, liquids, and gases. Now, if you don't remember the different phase changes that can occur, you're going to be able to see them in this graph. Now, at a low temperature and a high pressure, so in region A, you're going to find solids. Okay. In region C, where you kind of have a high temperature, but you also have a pretty high pressure, you're going to find liquids because those atoms are kind of smushed together. And B, when you have a lower pressure, so meaning you've got more room, more space for atoms to move around, and you're at a high temperature, so they're going pretty quickly, you're going to find gases. Now, in these processes, as a solid changes into a liquid, okay, we have melting, right? Now, when things melt, they take in energy. So that would be an endothermic reaction, okay? That's because it absorbs energy. In that case, we know that in order to go from ice to water, it has to absorb heat, okay? Now, when we go from a liquid to a gas, we know that's vaporization, okay? Now, vaporization, oftentimes people use the same word as boiling or evaporation. Okay, that is also going to be an endothermic process. And if we were to skip the liquid phase and go directly from a solid into a gas, that would be sublimation. For those of you who are in science engineering, we did the triple point lab where you were able to see dry ice and you could see it sublimate. Now, if we're going in reverse, say we're going from a gas to a solid, that would be deposition. Okay, we're going from a gas to a liquid, that is called condensation. You often see that happening on the side of your water glass. Okay, and if we go from a liquid to a solid, we call that freezing. Now, because those are the opposite, those are going to be called exothermic reactions, okay? And that's because they have to release energy in order for that phase change to happen, okay? And there are two key points on this graph. One is point D, and this is called the triple point. Now, the reason why it's called the triple point is because you can see solids, liquids, and gases at the same time. Okay, which is super critical. Okay, now speaking of critical, this point, point E, is called the critical point. Now, the reason why it's the critical point is this is where you get supercritical fluids. You're like, well, that still doesn't make sense to me. Well, supercritical fluids are when you can't tell if it's a liquid or a gas. And the answer is both. Okay? And so with this diagram, you need to be able to correctly draw and label this and be able to understand where the triple point is, where the critical point is, and how you would change and go about all of these substances.